Hello viewers, this is Wagda Ronald taking you through this tutorial for A-Level Applied Mathematics. In this video we're going to talk about the topic of motion in a Cartesian plane involving variable acceleration. Now these are the very questions I left in the previous video. I believe by now you've already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. Question 1 was got from UNEB 1993, paper 2, question 5b, and says a particle of mass 3 kilograms is moving on the curve described by r equal to 4 sine 3ti plus 8 cos 3tj, where r is the position vector of the particle at time t. Roman 1. Determine the position and velocity of the particle at time t equal to 0. Then part B, show that the force acting on the particle is negative 27 R. So we shall start with part A, we shall start with Roman 1. First of all, you know that R is equal to 4 sine 3t 8 cos 3t. So when t is equal to 0, it means that I have substitute for t here and here to come up with 4 sine 0 and 8 cos 0. So 4 sine 0 is equal to 0 and 8 cos 0 is equal to 8. Remember, cos 0 is equal to 1, so 1 times 8 gives you 8, while sine 0 is equal to 0, so 0 times 4 gives you 0. Therefore, velocity is got by differentiating displacement, so v will be equal to dr dt. Therefore, when I differentiate 4 sine 3t, I'll come up with, first of all, I differentiate the angle to get 3, so 3 times 4 to give you 12, which is here. Then sine becomes cos 3t. Then for 8 cos 3t, I'll first differentiate the angle to give me 3, so 3 times 8 gives me 24, which is this. Then after that, cos gives me negative sine. That is why you see here a negative and here is sine. So that is how they differentiate trig function sine and cos. So now that I've differentiated, I'll come and substitute when t is equal to 0, substitute for t here and here. So when I substitute here, I'll come up with 12 cos 0 and negative 24 sine 0. Remember, cos 0 is equal to 1, so 1 times 12 gives me 12. Then sine 0 is equal to 0, so 0 times negative 24 gives me 0. So in the end, I'll come up with 12, 0. So before we go to the next slide, let's see how much can be awarded for this slide. So M1 is for substitution and A1 is for the output. Here M1 is for the derivative, another M1 for substitution, and A1 for the output. So that is now the position vector and the velocity of the particle at time t equal to 0. Now we shall go to part Roman 2, which wants us to show that the force acting on the particle is negative 27 R. So here I'll have to first get the acceleration. So acceleration is got by differentiating velocity. So acceleration is called dvdt, which gives you negative 36 sine 3t and negative 72 cos 3t. Then I know that F is equal to ma, so I'll come and substitute for my m. For m I'll have 3 kilograms, but for a is this. So when I bring these two inside, I'll come up with negative 108 sine 3t and negative 216 sine cos 3t. But of 108 and 216 have a common factor, which is 27, and this negative is also common, so I'll first pull out negative 27 to remain with 4 sine 3t and 8 cos 3t inside. But I know that r is equal to 4 sine 3t, 8 cos 3t, I think, and you realize that's the same as this. Therefore, I'll come and conclude that f is equal to negative 27 r as required. So basically that's what they wanted, and let's see how marks on this slide could be awarded. So m1 for the derivative here, m1 is for substitution here, and b1 is for the output, then b1 is for the required expression. So basically that's what they wanted in this question. Now we shall go to question 2. Question 2 came from UNEB 2016, paper 2, question 13, and it says a particle starts from rest at a point 200 and moves such that its acceleration at any time t greater than 0 is given by acceleration equal to 16 cos 40 I, 8 sin 2tj, then brackets of sin t plus 2 sin 2t k meters per second squared. Find part A, the speed when t is equal to pi over 4, then part B, the distance from the origin when t, so here there is t, when t is equal to pi over 4. So first of all, this is the information given. Initial position is 200 and acceleration is 1640, 8 sin 2t and sin t minus 2 sin 2t. So for you to get velocity, I have to integrate acceleration. So I'm going to integrate the whole of this, and when I integrate, I'll come up with, for example, 16 cos 40 to integrate. First of all, you have to remember that for differentiation you multiply by the derivative of the angle, but for integration you divide by the derivative of the angle. So in this case, the derivative of 40 is 4, so I'll say 16 over 4 to give me 4, which is here. Then after that I'll say integrating cos gives me sine, which is there. So in the end I'll come up with 4 sine 4t. Then for this second part, of derivative of 2t is 2, so 2 divided by 8, I'll come up with 4, and that's where this 4 is coming from. Then when I integrate sine, I'll come up with negative cos, so this is where this cos is coming from, and this negative is also, that's where it's coming from. So in the end I'll come up with negative 4 cos 2t. Now for the last one, sine t, derivative is 1, so it means anything divided by 1 remains the same. So integral of sine will give me negative cos t. Then for this part, derivative of this is 2, so this 2 divided by the derivative of 2 gives me 1, that's why here there is 1. Then after that I'll integrate sine to come up with this negative cos. Now the negative, when I integrate sine, I'll come up with negative cos. Now the negative cancels with this negative to give me a positive here. After that I'll have to remember to add on the constant of integration. Then I'll come and say that when t is 0, v is 0, but in vector form, therefore I'll come up with, and in the end I'll come up with c being equal to negative 0, 4, 0. So C is 0, 4, 0. Now, and before we go to the next slide, let's see how much can be awarded for this part. So M1 for integration and B1 for constant of integration. So now that we have C, we shall come and substitute to get the final expression for V, which will be 4 sine 4t, then 4 minus 4 cos 2t, then negative cos t plus cos 2t. Therefore, when t is equal to pi over 4, so what you should remember again is that as long as there is a trigonometry function, always the calculator must be put to radians. So when I extend my calculator in radians and I substitute for pi over 4, for example, when I put pi over 4 here, to be pi over 4 times 4 to give me pi, which is this. Then pi over 4 times 2 to gives me pi over 2, which is that. Then pi over 4 times 4 here to times 2 gives me pi over 2, which is that. Then here pi over 4 remains pi over 4. Now that I use the calculator and I realize that sine pi is equal to 0, so 0 times 4 is 0. Then cos pi over 2 is equal to 0, which is that, therefore 4 times cos times 0 is that 0, but there is still this 4, so we put it here. Then cos pi over 4 is the same as 1 over root 2, but there's a negative, so we'll come up with negative 1 over root 2. Then cos pi over 2 will give me 0, which is that. Now when I simplify this, I realize that I come up with 0, 4, and negative 1 over root 2. Now that I've got the velocity vector, I can now get the speed, which will be equal to magnitude, which is 0, 16, and 0.5. So 0 squared is 0, then 4 squared is 16, then negative 1 over root 2 squared is 0.5. When I use the calculator, I come up with my answer as 4.062 meters per second. So let's see how mass can be awarded for this part. M1 is for substitution and B1 is for the output here. M1 is for the substitution and B1 is for the output there. So part B, remember they said find the distance from the origin when t is equal to pi over 4. So for me to get distance, I have to first get displacement, and displacement is good by integrating velocity. So when I integrate velocity, I'll come up with, so when I integrate 4 sine 4t, I'll come up with negative cos 4t. Then when I integrate 4 minus 4 cos 2t, I'll come up with 4t minus 2 sine 2t. And when I integrate negative cos t plus cos 2t, I'll come up with negative sine t plus 0.5 sine 2t plus the constant of integration. So now initially when t0 r is equal to 0, 0, it was given in the question. So when I come and substitute, I realize that my c is equal to 300. So for this slide, M1 is for the integration and B1 is for the constant of integration. So now that I've got the constant of integration, I come and substitute to get the final expression for displacement, which is that. But remember they wanted distance, so I have to first get when t is equal to pi over 4, what will be my expression for displacement. So my expression for displacement will be like that. And when I use a calculator, I'll come up with 1.1416 and negative 0.2070. Now that I've got displacement, I can get now distance from origin, which will be the magnitude, and it will be 4.1649 meters. So on this slide, M1 was for substitution and B1 was for the output. So output can be this one if you use the calculator, or this one you have simplified using standard angles or partial angles. So M1 is for substitution here and A1 is for the final output. So basically that's what they wanted. Now we shall go to question 3. Question 3 came from UNEB 2000 paper 2 question 11, and it says a particle moving with an acceleration given by a, which is 4 exponential of negative 3t, 2 sine t, and negative 7 cos t, is located at a point 5 negative 6 2 and has a velocity of 11 negative 8 3 at time t equal to 0. Find part A, the magnitude of the acceleration when t is equal to 0, part B, the velocity at any time t, and part C, displacement at any time t. So we shall start with Roman 1 with part A. So So we shall say that when t is equal to 0, acceleration is equal to this. So what you do is substitute for t, so it becomes 4e to power 0, and this becomes sine 12 sine 0, and this becomes negative 7 cos 0. Now a number to power 0 is 1, so this exponential of 0 is 1, so 1 times 4 is 4. Then sine 0 is 0, 0 times 12 is 0. Then cos 0 is 1, 1 times negative 7 is negative 7. Out of that we shall now get the acceleration. Acceleration is the magnitude of the acceleration will be 4 squared plus 0 squared plus negative 7 squared to come up with 8.0623. Now we shall go to part B. So part B, they wanted the velocity at any time t. So for you to get the velocity, you have to integrate acceleration. So when I integrate acceleration, I'll come up with, to integrate this, first of all, I have to differentiate the angle. So when I differentiate the angle, I'll come up with negative 3. Therefore, 4 divided by negative 3, I'll come up with this part, which is negative 4 over 3. Then after that, I rewrite the very exponential, which is e to power negative 3t. Then for this part, the derivative of this angle is 1, so it remains as 12. So this is why the 12 is here. Then when I integrate sine, I'll come up with negative cos. That is why the negative is here and there is cos there. Then for the last part, angle is, when I differentiate the angle, I come up with 1, so it remains negative 7, which is there. Then cos, when I integrate cos, I'll come up with sine positive. That's why you see now negative 7 sine t. Then don't forget the constant of integration. And before I go to the next slide, let's first see the marks for this slide. So M1 is for substitution and B1 is for the output. M1 is for the substitution and B1 is for the output. M1 is for the integration. Therefore, when t is equal to 0, initially v is equal to that. Therefore, when I substitute, I can be able to get the value of c as this, negative 37 over 343. And now that I've got c, I can get my velocity as this. So this will be the required expression for velocity in terms of t. So the marks for this slide, B1 will be for getting the constant of integration, M1 will be for substituting, and A1 will be for the output. Now we shall go to part C. Now part C, they wanted the displacement at any time t. So displacement, I have to integrate velocity. So when I integrate velocity, I'll come up with integrate velocity, I'll come up with this. Then I'll have to remember to add the constant of integration. Then after that, I'll know that when t is 0, initially the particle was at 5, negative 6, 2. So I'll come and substitute. And with that, I think I realized that I can get the constant of integration. Therefore, the constant of integration will be negative 49 over 9, negative 6, negative 5. Now, before we go to the next slide, let's see marks for this slide. M1 will be for integration and B1 for the constant of integration. So that I have to come and substitute for C so that I can get the final expression for displacement at any time t, which is that. So basically, that's what they wanted in this question. M1 will be for substitution, A1 for the output. So I believe you have marked yourself and checked your progress. So be reminded that now the next video will be on the topic of Newton's laws of motion. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on Newton's laws of motion has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.